here we are with the second part of section 4.5. We'll start out with interest problems. The formula is interest equals principal times rate times time. So that capital I represents how much interest was earned. P stands for principal. Principal is going to be the amount invested. R stands for our rate. T is for the time. And in these problems, the time will always be 1 year. And since it's always a 1 and multiplying by 1 does not affect our answer, we're just going to ignore the time. So in our example with interest problems, we're going to again use a table, and we're going to list our different accounts. We have a 7% account and a 5% account. We have our principal, our rate, and our interest. In the problem, it says we have $12,000 in total to be split between the 7% and the 5% account, and we don't know how much goes into each account, so those are going to be variables. The rate is going to be changing percent to decimal, and we don't worry about the rate in the total column. The interest, we are told that the total interest is $740. For the interest on the 7% and 5%, we're going to multiply together the rate and the principal. From this, we create our system of equations. And I solve this, I'm going to use elimination. I'm going to take the top equation, multiply it by negative 0.05. So I'm going to have negative 0.05x minus 0.05y equals negative 600. And when I add these together, the y's are going to cancel out. Solving for x, I get 7,000. So what that tells me is that I'm putting $7,000. X was in the 7% account. So I'm investing $7,000 at 7%. The total is $12,000. Therefore, I have $5,000 left over to invest at 5%. Our next type of problem is a mixture problem. A mixture is the blending of two substances to make a new product. Our first two substances are popcorn and caramel. Organizing in a table, our third row is going to represent the mixture. We are told we have 5 pounds of popcorn. We are mixing with caramel to create a mixture, but we don't know how much caramel, therefore we don't know how much mixture. So I'm going to represent those two with variables. The rate for the popcorn is 80 cents a pound. The rate for the caramel is $2.40, and we want the mixture to cost $1.40. So this will be An exception to our rule with our table, the mixture rate will have a value. However, it is not the sum of the two above. See, the number column, 5 plus C is going to equal M. And in our amount column, which we get by multiplying, it's going to be 4. And then multiplying and multiplying. So in our amount column, we can add 4 plus 2.4C equals 1.4M. But notice the rate does not add up. In fact, the mix is always going to be something in between the other two. Our system of equations, 5 plus C equals M, and 4 plus 2.4C equals 1.4M. This one is set up to solve easily by substitution. And put in the 5 plus C for the M. And then we're going to solve for C, and that'll tell us how much caramel we need, and that'll answer our question. Distribute. Subtract 1.4C, subtract 4, and we get 3. So we're going to have 3 pounds of caramel. Our next mixture problem, we're mixing ice cream, different amounts of butterfat. So we've decided that 9% butterfat is the best to sell. But we don't have 9%. What we have in our freezer or refrigerator is 5% and 15%. So we're going to mix those two together. We're going to mix together some 5% butterfat with some 15% to make 9%. We know that we want 200 gallons of the 9%, but I don't know how much of the individual amounts I need. The rate is the percent changed to decimal. And the amount is what we get when we multiply the previous two columns. 0.09 times 200 equals 18. Create our system of equations. Solve by elimination. I'm going to take the top equation, multiply by negative 0.05. So the x's cancel. And then I'm going to divide by 0.1, and I'm going to get that y equals 80. So y represents the amount of 15% butterfat. So we're going to have 80 gallons of the 15% butterfat. And since we have 200 gallons total, that means we're going to have 120 gallons of the 9%.